My name is Roman. I'm a software engineer. I like Go, playing video games and listening podcasts. I lived in Ukraine, in United Kingdom, in Austria, and now I'm living in Poland. And in open source, I've created things like ClickHouse data source, the first ClickHouse data source for Grafana, and some balancing proxy for ClickHouse as well. And for the last few years, I'm working on VictoriaMetrics. So VictoriaMetrics, it's an open source solution for monitoring. It collects metrics, processes metrics, provides interface for in Grafana for querying this metric. So if you didn't know about such a project, visit it on GitHub. It's open source, Apache 2 license. So yeah, please take a look. And what this talk is about, it's mostly inspired by experience of maintaining the project and especially open source project. And it's about complexity of distributed systems. It will be useful for people who like, or at least did, try to make dashboards in Grafana and are familiar with Grafana and Prometheus. Okay, so let's go. Oh, by the way, disclaimer, all of the content in these slides are generated by a human, not by AI. Roadmap. He provides a transparency for all the people to be able to use this project. Like, for example, Prometheus is a very good example of good open source project. It has all of this. And if you didn't put a star on that GitHub repo, I encourage you strongly to go and star Prometheus. But this is how it usually looks like in real world. There could be a brilliant software solving many, many problems. Code there, maybe adds a README file for 10 lines of code, like how to start it, and that's all. And maybe this project is indeed cool and people will start using it, but if the project itself doesn't have this transparency, doesn't have documentation, users will, the more questions they generate. And if there is no documentation, maintainer becomes a documentation of the project. So, and this is kind of a bad situation because everyone gets upset. Developer doesn't have much time to develop the project itself. He has to answer questions. Users are upset because they don't have the answers quickly enough, so they're likely to leave the project. So what we need to do, we need to convert black box into something transparent by adding all this stuff inside the project so users can answer on their own questions with help of documentation or with help with other community members. And then developer, a maintainer, could do what he wants to do, like improve the code, add more features to fix bugs, etc. Okay, so why this picture is here? Well, first of all, I find the title very interesting because it has the word monitor in it. And if you read it, like a shepherd and her dog monitor the sheep. I really like this title, and it's pretty elusive because you can think of shepherd as a DevOps, the sheep as an infrastructure or applications or services, and the dog, a tool that shepherd uses to monitor all this stuff. And it's pretty cool, but now imagine that you have not like 10 or 20 sheep. What about 1,000 sheep? Will it be enough to have one dog to monitor 1,000 sheep? Maybe shepherd needs to run a distributed system of the dogs to monitor all the sheep. And this is exactly like, imagine we need to monitor 1,000 sheep, and now we need to monitor distributed system of the dogs. And this becomes complex very fast. And when I need to demonstrate complexity of distributed system, I'm usually showing this picture. So this picture of Cortex, it's an open source monitoring solution based on the Prometheus, and it has many, many moving parts. Like, at least me personally, I find it complex. If I will have to run it, I will have to understand all this stuff. And if something goes wrong, I need a way to understand where it goes wrong and fix it. And maybe I will not have much time to do this. So what we can do to help people who are using this project to make it better? Well, from my experience of maintaining VictoriaMetrics, we can do the following things. We need to write good documentation. we need to instrument it with helpful logs and meaningful metrics, and we need to provide alerting rules and dashboards. And this is exactly what we'll be talking about right now. So VictoriaMetrics is also a distributed system. It also can be complex. There is no silver bullet. If you need to monitor hundreds of millions of active time series, it will be complex. And there will be questions on GitHub asking why something doesn't work good. And here's how we deal with that. Well, one of the tools is the Grafana dashboard that we provide. So this is how this dashboard looks like. It's shipped in, with every distribution of VictoriaMetrics. Like every user can install it and get all these numbers here. But does it actually explain to the user how VictoriaMetrics works? Well, if you first time log into this dashboard, the only thing you can say, well, all green and all good, right? But, okay, so what we can do with this. If you will try to Google how to make a good observability, how like to provide understanding of the system for users, you will find some recommendations, like recommendation of red method by Vworks. They will recommend you to have at least 3 signals describing your system. And it's very simple. These signals are rates, errors, and duration. For example, you have to monitor a web server. Web server accepts requests. These requests represent rate. These requests could fail, so we have errors. And these requests have latency. This is duration. So if we put all these 3 signals on the dashboard, we at least have some characteristic of the system. We at least can say if it's okay or not. There is a technique by Google called 4 golden signals. And this is the same as red, but plus 1 signal saturation, which usually stands for measuring the finite resources like CPU saturation, network saturation, disk saturation, etc. So we, of course, have the signals on the dashboard. So VictoriaMetrics can accept writes, it accepts reads, it can produce errors, of course, and there is latency for read requests, for example. So we have all these 4 golden signals on the dashboard, but the question is, are they actually helpful? Are they explaining the system? The problem of these signals is that they don't answer on the question why I'm having errors, why my latency is so high. For user, the system still remains a black box. It doesn't explain anything, it only shows the problem, indicates it. So what can we do? Well, Grafana doesn't provide, isn't a troubleshooting system. It doesn't provide you all these tools. So we limit it with the technology of our time, but let's at least try to do something, and we will try to utilize these info buttons on the Grafana panels. So in VictoriaMetrics cluster dashboard, we heavily use these help tooltips, and they're mostly next to every panel, and here's how they look like. So when user clicks on the info button, there is a description what this panel means, how to interpret it. For example, the lower the better, and you can immediately say that is it good or no. And then there is extra description like what you can do if it reaches the threshold, whatever, and further explanation given into the real mechanism how the thing works inside. You can go to the GitHub discussion, you can go to the documentation, etc., and understand something how it works. So the troubleshooting guide that we built using the dashboard looks like this. For example, user opens a dashboard, he sees this first of the signals, and there is an anomaly with that signal. So in this way, in this example, we have data points ingestion rate. It shows deep anomaly, right? What user should do? He should click on the info button, and there will be explanation what this panel means. And it says, hey, if you see problems with this graph, please go check VM insert metrics. And VM insert metrics is just another section on the dashboard. So user can go to the VM insert section, open the panels, and there will be probably another anomaly. In this case, there is a storage connection saturation panel that shows the anomaly. So user can click on info button again, and there will be explanation what this panel means and what needs to be checked. So it suggests that VM insert talks to some VM storage. This is stateful storage shards in VictoriaMetrics. And probably you need to check either saturation resources of VM insert or VM storage. So we follow the advice and we check resource saturation of the VM insert. And we see that actually there is no increase in saturation, it's opposite. VM insert resource usage goes down, so probably it's not VM insert fault. So let's continue following the advice and check VM storage metrics and the next anomaly of VM storage, explaining that, hey, that's probably caused by background merge. You need to check saturation of CPU and I/O. So following these 4 steps already gives some understanding for the user that it's not only writes into the black box, that inside there is a VM insert, and VM insert talks to the storage shards, and one of the connections to the storage shard was saturated. Something with this one single connection or with one single storage shard. So this kind of gives a context, a direction where user can take a look. Yeah, so that's the idea, is to hide the complexity of the distributed system, hide the complexity of the code and metrics itself. You don't need to run arbitrary expressions. You're just looking on the graphs and following advices, and you can indicate the malicious agent behind this. Okay, so we maintain these dashboards for a couple of years, and I would like to share the top cool features that we started to use with this time. Maybe you will find them useful from the practical perspective. So first is, of course, this help tool tips. I encourage everyone to put them on your panels and explain in a prompt way what the meaning. For example, we have some notion called slow queries. You may not have idea what it is, but the graph itself will tell you that it probably depends on this command line flag settings. If you want to change it somehow, it is very easy to find it. What else? We do not show all the components that we monitor. We show only outliers. So VictoriaMetrics cluster is a distributed system. It can be small, like 3 instances. It can be very big, like 100 instances. If I would like to show the memory usage of all the components, if I will put 100 of them on this graph, it will be a mess. I can't read it. I'm just a human. So what we do here is 2 things. Well, first, we show relative usage of memory. It's a percentage usage, because different components can have different limits on memory or on CPU or whatever. And also, we're not showing everything. We show the outliers per component. So VictoriaMetrics consists of 3 component types, and we show only those who consume the most, only those instances that consume the most of the memory. Looking at this panel helps me to understand pretty quickly if I'm okay. Like if something is 90%, I'm probably not okay, right? And you don't need to check 100 lines in order to understand that you are not okay. What you can do next when you found the outlier? Well, there is a very cool feature in Grafana. You can click on this panel, on the line, and it will take you to another panel that will represent you this metric in a different perspective. So in this case, we go from the relative representation of outliers to the absolute representation of all the components. This feature is super cool, but you know what is bad about this feature? Anyone knows? Do you know that this feature exists? Yeah, this feature doesn't exist, and Grafana doesn't, it exists, but you don't know about this, and Grafana doesn't help you to find, to show on the panel that you can actually click on the line. So I was thinking maybe we can enhance this, and I created a feature request to Grafana, which about creating alternative views for panels. So for example, I want to show CPU usage, and would be nice if I can click, if I can switch between 2 modes, relative mode and absolute mode. And this will be displayed in the title of the panel. So if you like this proposal, this is ticket 99861. Okay, let's go next. VictoriaMetrics components are mostly configured with command line flags. And we try very hard so users don't need to configure that. We have this meaningful defaults with optimal work of the components, but there are always some corner cases when something needs to be tuned up. And usually these corner cases is the main source of misconfiguration, of course. So in order to spot instantly if there is a misconfiguration, we expose every command line flag in form of a metric. And this metric called flag, and it shows you the value of the flag, the name of the flag, and if it was overridden by a user. So we have this panel with non-default flags. And I can instantly see that someone said like they want to select 250 million of unique time series per request, which probably could lead to problems with memory usage when you do this. What next? We heavily use annotations. So we expose the versions of the component in the form of a metric. So we then can build an annotation query, which will show on the graph when version of any component has changed. And it's like a no-brainer. If you see the annotation on the graph and something went bad after that, some performance degradation, you don't need to think, you just roll back. And then you investigate that something, what actually caused that. We also use annotation for restarts. And restarts could happen in many cases, but it could be also out of memory exception. If something crashes because of lack of memory, you have to take a look on that. Or if you change the command line flag, you also had to restart it. So probably user changed configuration when they did this. What else? Of course, VictoriaMetrics components produce some logs, warning, errors, etc. And we expose that in the form of metrics as well. And even if I don't have access to the logs of the components, I still can check them on the panel in Grafana, and they have this label pointing to exact line of the code which produced this error. And since the source code is open, I can just check which line of the code produced it, and I can guess what is the error without having to take a look on the logs itself. Yeah, all this dashboard goes out of the box, and we recommend in our best practices to use the dashboard, and we encourage everyone to use it. And we also ship it with the alerting rules, which we think are very helpful to understand if system is okay. This is how alerting rule looks like. It contains the similar context, the summary and description pointing what the problem is and how to solve this. And also they contain a link to the dashboard, the same dashboard that I showed you. So if you use our alerting rules and our dashboard, and you receive the alerting rules firing, you can just click on the link, and it will take you to the panel which explains what's happening here. And you will get the context, what happened before. You will have the information tooltip with recommendations. And yeah, I think this interconnection between alerting rules and dashboard is pretty helpful. At least it helped me to troubleshoot it much faster than before. All this is also depends heavily on the documentation. I ran this command like 2 days ago, and it says that we have 90,000 lines of documentation in the project itself. It doesn't mean that we add documentation every day. We constantly refine it, trying to make it clear. But yeah, this is what it takes to describe the distributed system. And when we accept pull requests, we also require from user not only to make a code change and test, we also require to make a documentation change, because if you introduce a new flag or change the behavior of existing flag, this should be reflected in the documentation, because otherwise it will go unsynced pretty fast. Oh, and another feature that we use in the documentation that I started using not so long ago is the version label. So when we introduce a new feature and we merge into upstream, our documentation renders it instantly. And some users, when reading the documentation, they can find a feature that doesn't still exist in their version at least. So we have this macro in Markdown that called available from, which points to exact version when this feature was introduced, and user can get from the documentation when this flag was added. Of course, there is an automation. You don't need to put exact version. You can put a placeholder in it, and then on release, it will be automatically replaced with the actual version for you and published with the latest tag. Okay, so as I said, we cross-refer our documentation to keep it fresh. We use documentation links in our dashboards, in our alerting rules, in our code, in every public platform where we help users to answer their questions, and this is what helps us to keep it up to date. And we also do really care about broken links. If something was answered on the GitHub like 3 years ago with the documentation link, it still should work, even right now. So if you find any broken links in our repo, just let us know. We're really trying to keep them live. And yeah, we do care about all this that I showed. All this is available in open source, and we really want you to use that. And we really do care about this because we use it every day. We dog food, the same dashboards and alerting rules internally. So VictoriaMetrics provides enterprise support to customers, and those customers can send their telemetry to our cloud. So we're basically receiving the same metrics of the VictoriaMetrics component to our cloud, and then we can reuse the same dashboards that I showed you, the same alerts, and refer to the same docs. And this is how it usually looks like. We have support engineers who receive the triggered alerts. These are software engineers, the maintainers of VictoriaMetrics itself. So when they receive an alert, they can immediately see if this is a meaningful alert, if it's a false positive or not. And if it is a false positive, maybe it needs to be changed in the upstream. Then they go to the dashboard and they check the same panel, and they also can apply any modifications to it, maybe make it more clear to change the description, etc. Then we apply changes in the upstream in the first place, and then from the upstream it goes to the internal system. And yeah, then system back again to the green state. So this is why it's called monitoring of monitoring, and this is how we use our own dashboards and alerting rules. Yeah, so you can check our dashboards in our public playground. All this again is public. You can try it, you can see all the descriptions, you can play with expressions, you can check our alerting rules and documentation. And that's it.
So thanks a lot. Are there any questions? There's a question.
Thank you for the brilliant talk. I would like to ask you about monitoring of monitoring. Actually, where some kind of heartbeats or something like can show you that monitoring is actually broken.
The
heartbeat,
question,
for example.
If we have automations that shows that monitoring is broken?
Yeah.
Well, of course. If you check our best practices documentation, it suggests that every monitoring should have a monitoring of monitoring. So basically, we run two VictoriaMetrics systems that monitor each other, like cross-monitoring. If something dies, the another system will let you know.
Is there one more? Oh, yeah, here.
And do you then have also different infrastructure for these two instances? Because we have at the moment this problem that we would like, for example, Loki with an object store backend, but Loki is also collecting logs of our object store solution. So we don't really want to depend our Loki on the thing that Loki is monitoring.
Yes, so the question is, do you need to have a different infrastructure to cross-monitoring? Yes, that would be the best way how you can do this. They need to be independent, for sure. If you can afford that, if you can do that, implement, yes, I recommend to do this. But you also can use kill switch mechanism, if I'm not mistaken. Like if, yeah, you're right, basically. But there are cheaper ways to do this, to at least notify you that your monitoring is broken.
More questions? Yeah.
When you had the list of errors, number of errors or warnings in the logs, could that cause any issues with cardinality?
So the question is, if I have many logs with errors, does it cause issues with cardinality? No, because the number of lines with the errors is limited. It's finite. So if we count the number of unique logs, it probably could be 100 at max, but I believe it's much lower, so it doesn't cause. It just looks dangerous. It is not in reality.
Anyone? Oh, up there.
Hi, thanks for the talk. I really like the section with the tooltips on the dashboards. But to be honest, I never would have thought of this myself. And I guess my question is, once you first started getting users onboarded on this dashboard and your tooling in general, how did you make sure that these features and this documentation is discoverable enough for people to actually RTFM? Thanks.
So the question was, how do I find that people actually use the information tooltips and if they are helpful? Yeah, so we don't have any way to know that, but we have a lot of questions on the GitHub and public platforms. And here's how we can make our support better. So we first thing that we ask is, can you give a screenshot of your Grafana? And we also have troubleshooting checklists that we also have a link and we share it with the user. And there is a steps like what you need to do, like check this panel, read the stuff. And yeah, there is no clear way, but this is how we usually help people. We let them know that this exists. And then community is supposed to take it off from there.